In this lesson, you will learn how to find the mean and standard deviation of a discrete random variable, as well as determine if a game is fair. What I'd like you to do first is just find the mean of these 5 numbers, 0, 1, 2, 3, and 4. Take a quick second to do that on your own. It's not a trick question. You learned how to take a mean or the average of a set of numbers probably years ago. Pause here if you need more time, and press play when you're ready to continue. So what you probably did was add the numbers together and divide by how many there are in that set. In this case, 0 plus 1 plus 2 plus 3 plus 4, all divided by 5. That should give you a mean of 2. Now let's find the mean of x with the probability distribution shown here. How will we find the mean of this using what we already know about means? Say that we have 10 people in this population. How many of these 10 people have 0 siblings, or 1 sibling, or 2, etc.? What we can do is use this probability distribution to answer that question. So if we have 10 people in our population, we know 20% have 0 siblings by looking at the probability distribution table. Therefore, out of my 10 people, 2 of them have 0 siblings. 20% also have 1 sibling, so 2 of them have 1 sibling. 3 would have 2, 2 would have 3 siblings, and 1 would have 4. So if I were to list all those numbers out, here are our 2 people with 0, our 2 1s, our 3 2s, our 2 3s, and a 4. All we're doing is taking our probability distribution and using it to look at a population of 10 people. Now, let's find the mean of this population of 10 people. We can do that based on what we learned years ago about averages. If we look at these 10 numbers, we'll add the numbers up and divide by 10. That gives us 1.8. Now, I know I don't need to explain this further to you, but what I'll do is rearrange a few things so that we might see it in a different light. So instead of writing 0 plus 0 plus 1 plus 1 and so on, I'll just group the numbers together. So what I have here is 2 zeros. That's what I've notated here. 0 2 times. Plus, I have 1 2 times. Plus I have 2 3 times, etc. I took those 10 numbers and I just grouped them together to get what you see here. I haven't changed anything, I just rewritten it. Well, what if I take that denominator and give it to each one of my terms? What I end up with is that 0 and 2 divided by 10, or 0 times 2 tenths, or 0 times 0.2. I can do this for each one of my terms. So just by rewriting again, you get what you see here. Now those numbers should look a little bit familiar. If you notice, that 0 is in our probability distribution function, and that 0.2 is also in our probability distribution function. Actually, you can see all 5 of these terms in our chart. So really, what I'm doing is taking 0 times 0.2 and 1 times 0.2. And then I do this for the next column and the next column and the next column. If you notice, when I multiply down, I get these 5 terms. The last thing I need to do is add across. That gives me my mean, which is 1.8. When you're asked to find the mean of a discrete random variable, what you'll do is you'll multiply, 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 add. One more time, you'll multiply, 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 add. And that'll give you the mean of the discrete random variable. Now, for those of you thinking, hold the phone, where's the dividing? Because when you learned mean in your earlier school years, you likely always divided by how many elements you have. It doesn't look like we're dividing, but we're actually doing it in a sneaky way. When we multiply by a 0.2 or a 0.3, you can actually think of that as multiplying by 2/10 or 3/10. So in actuality, you really are dividing by some number. In this case, I use 10 as my example. So when you're multiplying by that decimal or fraction, you are inherently dividing and thus finding your mean. One more thing before we move on. Remember, when we found the mean of just 0 through 4 without the chart, that was 2. So why is the mean lower than that or even different from that? In this case, 0 through 4 are not equally likely. You're more likely to have 0, 1, or 2 siblings than you are to have 3 or 4 siblings in the chart. So the mean of this distribution will lean toward the lower values, hence lower than 2. This is why we have to use this method to find the mean. Because when you multiply, 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 add, you're taking into account how each one of those outcomes are weighted based on the probability. Just so you are aware, there is a formula for mean, and it is mu of x equals the sum of x sub I times p sub I. This just means I take each value of x that the random variable takes on and multiply it by the corresponding probability and then add them. This is the same idea as multiply, 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 add. But notice, there is also this e of x. This is the expected value of x, or expected number, which is the same as finding the mean. So when you see or hear expected value, I want bells to go off in your head. They should go mean, 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 and that's what you'll be finding. Now let's shift to looking at standard deviation. What I'd like you to do is dust off the rust and try to find the standard deviation of 0, 1, 2, 3, and 4. As a reminder, we made a chart to find standard deviation. I put my x's in the first column, in this case, 0 through 4. Our second column is x minus the mean, because remember, standard deviation measures the average distance a data point is from the mean. So let's find out how far away these x's are from the mean. Our mean was 2, so if I take each of my x's and subtract 2, I get this column. Then we had to square it, because if we add all of these right now, everything would cancel out and we'd always get 0. So we square everything to get this column, and we add it up to get 10, and then we divide by n minus 1. So if I take 10 divided by 4, which is the number of values minus 1, I get 2.5. Recall, we're not quite done. That's our variance. So we need to take the square root of that to find our standard deviation. This might not have been in the front of your brain, remembering how to do the standard deviation, but it is important to know how to do this in order to move forward with random variables. If you need to do another example, go right ahead and practice before you move on. Let's find the standard deviation of x with the probability distribution. If you recall, the mean was 1.8. And the good news is that we'll start the same way. I'll have my chart that has my column of x's, my column where I take my x's minus the mean, and my column where I square everything. So far, nothing has changed. We haven't taken into account the probabilities in the probability distribution function. So what I have to do now is take each one of my values in my x minus x bar squared column and multiply by the associated probability. For example, for x equals 0, the probability that goes along with that is 0.2. So I'll take 3.24 times 0.2, and that gives me 0.648. I'll do this for each one of my entries. So one more I'll talk through is when x equals 1. The probability that x equals 1 is 0.2. So I'll take 0.64 times 0.2, and that gives me 0.128. You need to do this for each one of your x values to get what you see here. That's the new column. You are multiplying by the associated probabilities. We didn't have probabilities when we did standard deviation just for a set of numbers. Now we do, so we need to incorporate them. Like we did before, we sum up the final column to get 1.56. Now, normally at this point we would divide, but we don't need to do that here because when you're multiplying by these probabilities, you are inherently dividing. So this answer right here is your variance. In order to get my standard deviation, I have to do one more step, which is square root that number. In this case, we take the square root of 1.56 to get approximately 1.249. And that's the standard deviation of this random variable x. Let's practice more with an example. In example 1, find the mean and standard deviation for x, which represents the number of times a family goes out to dinner on the weekend. And I'm assuming here that the weekend is Friday, Saturday, and Sunday, given this probability distribution. Pause the video to try this on your own. Press play when you're ready to continue. For example number 1 solution, to find the mean, remember we multiply, 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 add. In this case, you'll get a mean of 1. To find the standard deviation, you want to set up that chart. I know it seems like a lot of work, but for me, it's the best way to organize it. Some people like to try to do this in a linear fashion. You may absolutely do that. I like the chart. If you like the linear fashion, go right ahead. In any case, I get the sum of 1, which is my variance. And if I square root that, I get a standard deviation of 1 as well. So the mean of x is 1, and the standard deviation of x is 1, in this particular case. Many times you'll see the mean and the standard deviation denoted like this: mu sub x and sigma sub x. Let's try another one. In example number 2, let the random variable x represent the number of life insurance policies a sales associate named Joyce sells on any given Monday. Joyce estimates the following probability distribution for herself. Based on the information provided, for A, find the number of life insurance policies Joyce is expected to sell on any given Monday, and for B, find the variance and standard deviation for x. Pause the video to work through this, and click play when you're ready to move on. Here's the solution to example 2. To find the mean of any discrete random variable, what do? Multiply, 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 add. And in this case, we get 0.45. If we do our chart to find the variance, we end up with 0.3475. The square root of that is approximately 0.589. So the mean of x is 0.45, and the variance of x is 0.3475. And the standard deviation for x is 0.589. Before you move on, some of you might be thinking, well, how did I know to find the mean for part A? Because it didn't say that. It said, how many life insurance policies is Joyce expected to sell? Remember when you see the word expect, the bell should go off in your head saying mean, 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 mean. That's what you want to find, the mean of X. Now let's test what you've learned so far with a check for understanding. Let the random variable X represent the amount of money won in a friendly game. Here's the probability distribution for X. I want you to complete the following. A, find the expected value of the game. And B, calculate how much you would pay to play this game in order for the game to be fair. Pause the video to work on this. Press play when you're ready to resume. Here's the solution to this check for understanding. Again, part A says to find the expected value of the game. Remember when you see the words expected value, I want mean to light up in your head. Mean, mean, mean. So to find the mean of this probability distribution, I'll multiply, 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 add to get my average of $6. That means I would expect to win $6 every time I play. Part B asks, how much would you pay to play this game in order for the game to be fair? Well, what does fair really mean? Everyone has their own definition of fair, but mathematically speaking, when we're talking about a probability distribution, for a game to be fair, the amount paid to play needs to be equal to the expected value of the game. You should pay $6 for the game to be fair. So your answer to part B would be the answer to part A. Since your expected value is $6, in order for the game to be fair, you were charged $6. Let's say I was charging you $10 to play this game. Well, that wouldn't be fair because you're paying $10, but you're only expected to win $6. That's not a fair game. So when you're thinking about fairness in terms of random variables and probability distributions, you want to think, does the mean or the expected value equal the amount you're expected to win? If they're equal, the game is fair. Let's go to the wrap-up. After this lesson, you should be able to find the mean of a discrete random variable and find the variance and standard deviation of a discrete random variable. This takes a little bit of practice, but I know you'll become an expert at it. That concludes this lesson on mean and standard deviation of a discrete random variable. Remember, you can review this video as many times as needed for better understanding. Thanks for watching.